Hey everyone, so in this video we're going to look at the animating of the opening of doors such as on cabinets and cupboards, as well as opening doors between buildings, as well as the opening of drawers, again from cabinets and cupboards. So for this particular tutorial you can use whatever assets you want. I'll be using the Sci-Fi Interiors pack by Tint Studios. Again, you can use whatever you want. It's just I purchased this recently, so I've been doing a series showing how to implement these in your games, in your projects. So we're just going to start with the cabinet. And there's really two attributes that matter, okay? So first of all, the object that you want to animate, such as the door or the drawer, it needs to be its own separate object. So if this cabinet was one molded object, obviously you couldn't do it. Each object needs to be separate and individual. So you can see the door is a child object. Over here in the inspector, it has a transform, it has a box collider, so it needs to be its own object. Second of all, for the doors, since you want this to pivot along the edge as if there's a hinge, then the pivot for the object needs to be along the edge, and sure enough, it already is. As you can see, that's where Mesh Tint put it. I have no doubt that that was intentional to facilitate animation. So if you rotate this, you can see it does properly open along the edge. So those are the two attributes that matter. Now, if you're using this package by Mesh Tint, there's a couple other things you need to know. One, by default, these are set to static, so you have to undo that or else it won't animate. Two, the cabinet itself has its own collider, and if you notice, the collider extends out. So technically, you're never actually clicking on the door. If you leave it like this, you're clicking on the cabinet collider. So you just need to edit the collider for the cupboard as a whole so as that the collider is behind the things that you need to click on. Okay, so that's the prep. Now, as far as how to actually do this, you need to have a box collider so that it can detect a mouse click. So these already have colliders. So if we click on this one, you can see, again, it has its own box collider. Now I'm going to set it to trigger, and the reason for it is everything is really tightly packed, and so if things start bumping against each other, you might get results that you don't want. So I'm going to set it to a trigger. That way, if there's any collision, it'll just clip through and it will keep going. Alternatively, what you could do is you could just trim the collider a little bit in each direction. That way it doesn't clip, six one way, one half dozen the other. Your choice how you wish to handle the door. So I'm just going to make it a trigger to make it easier. Okay, so we need a box collider to detect a mouse click. Two, we need a rigid body to apply angular velocity. So add component, physics, rigid body. We're going to get rid of gravity or else it'll just drop through the floor. And then we're going to add some angular drag. I don't recall what the right number is. It'd be a bit hit or miss. But let's try one. Okay, so we've added a rigid body so is that we can add angular velocity. Now we just need a script that controls that. We have a script. I already typed it out, so it's going to be a little bit more detailed than what I normally like to start with. But people said they did not like to watch me type. But we'll walk through the whole thing. So first of all, you're going to need a variable for each object that you want to animate for a couple reasons. One, you want to know if it's in an open state, a closed state, or is it in a mid state where it's opening or closing. We'll get into that a little bit more as we get into the code. So there's two doors and two drawers, so technically you'd need four. I'm only doing two because if you can do one door, you can do the other. If you can do one drawer, you can do the other. Okay, nothing in start because nothing's happening when it instantiates, nothing in update because we're not checking anything on a frame-by-frame basis. So on mouse down. So first, we're checking to see which object we're clicking on. So that's self-explanatory. If gameObject.name is equal to door left, and it is case sensitive, so you have to make sure you spell it right. So if we're clicking on door left, what do we want to do? Well, it depends. Is it open or is it closed? So if is LD open is equal to no, and that is the default value, then we want something to happen. We added a rigid body, so we said, okay, well, let's modify that rigid body now. We're going to add angular velocity to it, and it's going to be 0, 3, 0. So remember, this is pivoting as if on a pole vertically, so that means it needs to be the y-axis. So get component, rigid body, angular velocity, new vector 3, 0, 3, 0. And this is arbitrary. You can choose how fast or slow you want it to open. There's that variable. And now, if you notice, we don't change it immediately to yes because it's not actually opening. It's not actually open, excuse me. It's in the process of opening. So we want to detect that it's in the process of opening, because if we just immediately change this to yes, you could click on it again and start to close it, and that would mess things up. And then this is just the coroutine that is going to change this variable to y or to n. So again, if is LD open is set to no, we add angular velocity. We change this to O to indicate that it's in an opening state and to start the coroutine. Else, if is LD open, yes. So now we're checking, we're doing the same check, but now we're saying, is it yes? Then we reverse. So this is not new functionality. This is rinse and repeat. Get component, rigid body, angular velocity, new vector 3, the same absolute value. It's just a negative now, negative 3, comma 0. Is LD open? Now we're going to say C to say that it's closing as opposed to closed. And start coroutine, stop door. Okay, so we're not going to do the second half because that's for the drawer. We'll do that in a minute. So that controls the door. Start coroutine, stop door. So we're going to jump down to that. Start stop door. So when you say start coroutine, it runs this. So IEnumerator stop door. Yield return new, wait for seconds. This is how much time it takes for the door to open and close. It's not exactly right. It's probably more like 2.5 seconds, but good enough for our demonstration. So yield return new, wait for seconds 2. Don't worry about what yield return new means. Just know that you have to type it, and ultimately the upshot is that you're creating a 2-second delay before anything else in this section will execute. So after 2 seconds, it says, is LD open set to O, meaning that's in the process of opening. We'll now change it to yes. So in other words, it's going from an opening state to being open. Is LD open closing, excuse me. So if it's closing, now change it to say, no, it is not open, and therefore it is closed. So if I haven't forgotten anything, I believe that's all we'll have. Let's do a quick check. So the door is no longer static. We changed it to a trigger. We added the rigid body. Like I said, we might have to tweak the angular drag. We got rid of gravity. We have the script to check for the mouse down. All right, let's run this. So I'm going to click, and sure enough, it opens. And actually, that's just about right. It kind of slows down a little bit too long, but not a big deal. And now we'll close it. And again, since we're using the same angular drag, we're using the same angular velocity, this should be nice and even. It should go back to its original place. Now I'm going to click really fast. Okay, I clicked a bunch of times and it did not immediately close because we have that extra status of being in an opening or closing status. So you have yes, open, no, closed, as well as O for the process of opening, C for the process of closing, and we'll close it again. All right, so now rinse and repeat for the drawer. So for the drawer, we need to make sure it is not static. We need to make it a trigger. Now, I do want to call this out. If you want an object to actually be sitting in the drawer, if this is trigger, then you won't be able to do that because it won't move with the drawer. So in this case, you might want to take the alternative that we already mentioned, which is you just trim in the edges a little bit. That way something can indeed sit in there. But if you don't want people to actually need to see the object, it's just binary. That is, if you open the door, you automatically get what's inside. You don't have to search. You don't have to see. You just get it. Then you don't have to worry about that. That is purely a creative choice. But I do want to call that out. If this is a trigger and you've got something sitting in that drawer, it won't come out with the drawer because this is a trigger. It's no longer a solid. So it's a trigger. We said we needed physics. We said we needed rigid body. Going to get rid of gravity. This time we don't care about angular drag. We care about regular drag because it's just velocity, not angular velocity. And we need our script. So again, be a bit trial and error with the actual drag. Actually, I just tested, I paused and tested it, and that's not enough drag. So let's try like 2. And let's raise our camera up. Actually, it's already pointing down. Yeah, that's fine. Okay. I was going to raise it up a bit, but we should be able to see what's going on. Okay, so we have our drawer. We said that we got rid of static, just like the door. We have our trigger collider. We have 2 drag now. We got rid of gravity. We have we can minimize that. We have our script, and let's review the script. This is really rinse and repeat, so it looks messy, but it's really the same principles over and over again. I cannot stress that enough because sometimes when I show how to reverse something, sometimes people don't seem to understand that it's really the same thing, just in reverse. Okay. Now, in this case, it's not so much reverse, it's so much as applying the principle to a different object. So this should look very, very similar. So in the on mouse down section, GameObject.name equals drawer top. So obviously we're checking for a different object. We're going to check a different variable because you can have multiple objects open or closed. You can have a door open and a drawer open, one closed, 2 drawers open, 1 door closed, so on and so forth. So is TD open? And again, like if you want to differentiate this, you could do DR for drawer. So is TD open? No. And then the same thing, get component, rigid body, although this time it's velocity, not angular velocity. And this time it's on the Z axis because it's coming out towards the camera. Okay. Is TD open? We again indicate that it's in the process of being opening. So we're using O to say that it's in the process of opening. You can use whatever you want. And then it has its own coroutine, which is going to look very similar to the one we just looked at. And then you just check to see if it's already open. Else, if is TD open equals yes, then again, get component, rigid body, velocity, new vector 3, again, same absolute value, so just the opposite direction. Is TD open? Indicate that it's in a closing status, and then stop drawer. And then we just go to stop drawer. Same thing. You look, these are almost identical. Yield return new, wait for seconds too. This time we're saying is TD open rather than LD open. So if it's in currently the opening status, change it to completely open. Is it in a closing status? Change it to being completely closed. And let's run this. There we go. Just about right. And now if I click on again, it closes. And again, nice and flush because it's exactly the same calculation forward and back. Now if I click a second time, you probably couldn't hear it, but I clicked again and it didn't automatically close. Because again, we have that check in there to say, is it opening? Is it closing? So is it in the status of opening or closing? Because if you didn't do that, you could click again and reverse it and it would mess it up. Okay, so I think that's it for this video. If there's anything you'd like to see, just let me know, leave a comment, and I can do a video about it, hopefully. The same principle would apply to doors going in and out of rooms. Like I said, this could easily be a door between rooms. The principle is the same. The only difference is if, say, you were, again, I mentioned a revolving door, then in that case, the pivot would be the middle. So if you want, I could do a separate tutorial for that. But honestly, it's the same. It's angular velocity, but it's just that the pivot is in the middle, and so it will respond accordingly. So I think that should about do it. I hope that you found this useful, and do please enjoy the rest of your day.